Hello viewers, welcome to my channel. I'm Hasham. So far 8 problems I have completed on transportation. Now in this video 9th problem I am going to explain. In this problem 2 more new points I am going to explain. The first new point is the problem is unbalanced. So far 8 problems we have done where the problems were balanced problem. Total supply and total demand both were equal, but in this problem it is unbalanced. So we have to make it balanced and then we can find out the IBFS. That is a new point. Second new point is our all opportunity costs are not going to become positive. One of the opportunity cost we are going to get negative. When we get negative opportunity cost, the solution is not optimum. We have to change the allocations by making a loop. That's what I'm going to explain. So very important video. Watch the video till the end. Don't skip in between. So now before starting the 9th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain all the points in detail. Come on. Now I am starting the problem. Solve 9th problem. Solve the following transportation problem whose cost matrix availability at each plant and the requirement at each warehouse are given as follows. So the supply is from the plant and the requirement is at the warehouse. The origin is plant, destination is warehouse. So 3 plants are there, P1, P2, P3, and warehouses are W1, W2, W3, W4. Availability is 5,000 plus 4,000 plus 7,000, that is 16,000, whereas requirement is 3,000 plus 2,500 plus 3,500 plus 4,000. It comes to 3, 4, 5, 6, 7, 8, 9, 10, 13. Only 13,000 is the requirement, whereas supply is 16,000. It is unbalanced. This is the new point. So to first of all we have to make it balanced and then we proceed to find out the IBFS. Now see here, total availability in the plant are 5,000, 4,000, 7,000, 16,000. Total requirement at the warehouses 3,000, 2,500, 3,500, 4,000, 13,000. The difference is 3,000. The 3,000 units is short at the warehouses. We have excess supply. From the plant we have excess supply, whereas the demand is less. The requirement is less. So how to make it balanced one? The problem is unbalanced. Availability is more than requirement. So we make a dummy warehouse whose requirement is 3,000 units with 0 cost. This is the new point. Our requirement is less. So we open a dummy column because columns total is only 13,000 whereas row totals are 16,000. This row total is 16,000 whereas column total is only 13,000. So we make a new column. So we will open W1, W2, W3, W4 plus dummy. For this dummy column, the requirement is 3,000 units and the unit cost will be zeros. In this way, our problem will become balanced. Now, if you take the total of this row and total of column, you will get 16,000. That is the new point. Now, finding the IBFS by BAN. So 3 rows, P1, P2, P3. And warehouses are 1, 2, 3, 4 warehouses and 1 dummy total, right? And the requirement is given, availability is given, and unit cost 15, 25, 12 already given in the problem. I have taken it. Now penalty. Now we'll start the penalty. Already so many problems we have done. Penalty is the difference between the smallest cost and the next smallest cost. In the first row, the smallest cost is 0. Next smallest cost is 11. The 11 minus 0 is 11. The next penalty, 0 is the minimum. Next minimum is 14. The 14 minus 0 is 14. Here the minimum is 0. Next minimum is 12. The 12 minus 0 is 12. The row penalty completed. Now column penalty. The minimum in the column is 12. Next minimum 15. The 15 minus 12 is 3. Minimum is 12. Next minimum is 20. The 20 minus 12 is 8. Here the minimum is 11. next minimum 14. 14 minus 11 is 3. Here the minimum is 12, next minimum 13. So 13 minus 12, 1. Here 0. That's all. Now what is the highest penalty? The highest penalty is 14. The highest penalty, 11, 14, 12, 3, 8, 3, 1, 0. The highest penalty is 14 in this row. In which row we are getting? P2. Now find out what is the minimum cost in this row. In this row the minimum cost is 0. So we make the allocation in this cell. Row total 4000, column total 3000. So we allocate 3000 in this cell. Right? So 3000 minus 3000 will become 0. And 4000 minus 3000 will remain 1000. Now column is blocked. Column becomes 0. So we block the column. First penalty completed. Now I am coming to the second penalty. Right? The minimum is 11. Next minimum 12. The 12 minus 11, 1. This one. Minimum is 14. Next minimum is 16. So 16 minus 14, 2. Here minimum is 12. Next minimum is also 12. So 0. Right? Column wise. Minimum is 12. Next minimum 15. So 15 minus 12, 3. Here minimum 12. Next minimum 20, 8. Minimum 11. Next minimum 14. 14 minus 11 is 3. Minimum 12. Next minimum 13, 1. Now see, what is the highest penalty? 1, 2, 0, 1, 3, 8, 3. So 8 is the highest penalty. Round off the 8. In which column we are getting this 8? W2 column. So what is the minimum cost in this W2? 12. So fill up this cell. In this cell, the row total 7000, column total 2500. So whichever is less. So 2500 is less. So I am allocating 2500 here. This will become 0 and 7000 minus 2500 will become 4500. 4, 5, 6, 7. So 4500. The column has become 0. So block the column. Block the column. That's it. 2 penalties completed. Now I am coming to the third penalty. Right? Third case. Minimum is 11. Next minimum 12. The 12 minus 11 is 1. Here the minimum is 14. Next minimum 16. So 16 minus 14, 2. Minimum is 13. Next, 12. Minimum is 12. Next minimum is 13. So 13 minus 12, 1. Now column wise. 12 to 15, 3. Here it is exhausted. Put a dash. So 11 to 14, 3. Here it is 12 to 13, 1. Here it is dash. Now, what is the highest penalty? 1, 2, 1, 1, 3, 3. The penalty, there is a tie. Highest penalty is 3, 2 times. Whenever there is a tie in penalty, we compare the cost. Wherever cost is less, we allocate. If we select this 3, the minimum cost is 12. If we select this 3, the minimum cost is 11. The 11 is less, so we select this 3. How much allocations we can make in this 11 cell? Row total 5000, column total 3500. So we allocate 3500. 3500 are allocated in this cell, right? 5000 minus 3500, 1500. And this 3500 will become 0. So block the column. That's all. 3 penalties completed. Now I am coming to the fourth penalty. Right? So 12, 15. So 15 minus 12, 3. Here it is 16 to 25. So 4 plus 5, 9. Here it is 12 to 13, 1. Right? Now column wise. 15, 12 to 15, 3. Here it is dash, dash. Now here 12 to 13, 1 dash. That's all. Now what is the highest penalty here? 9 is the highest penalty. So round off this 9. In which row we are having this 9? P2. What is the minimum cost here? 16. The minimum cost is 16. So we allocate row total 1000, column total 4000. So we allocate 1000 here. Right? This 1000 minus 1000, 0. 4000 minus 1000 is 3000. Now this has become 0. So row is blocked. The row is blocked. That's all. One more penalty we require. So here 12 to 15, 3. Here it is blocked, dash. 12 to 13, 1. Now column wise, 12 to 15, 3. Here it is dash, dash. 12 to 13, 1, dash. The highest penalty is 3. And here also highest penalty is 3. So if we select this 3, what is the lowest cost here? 12. If we select this 3, the lowest cost is 12. There is a tie in penalty and there is a tie in cost also. Right? So we see the allocations. Where we can give more allocation, then that we will select. If we select this 3, this 12, how much allocations we can give? Row total 4500, column total 3000. So 3000 units we can allocate here if we select this 12, right? If we select this 3, again 12, how much allocations we can give? Row 1500, column 3000. So only 1500. If we select this 3, only 1500. If we select this 12, then what will happen? 3000 we can allocate. The more allocation from this cell, this 3. So we select this 3, this is the minimum 12. Here row total 4500, column total 3000. So we allocate 3000 here. This will become 0 and here remains 1500. Right? This column will be blocked. That's all. 5 penalties we have completed. Now we don't require any other penalty. If any row or column having a single unoccupied cell, we will take the balancing figure. Now, in the first row, only one unoccupied cell is there and the row total is 1500. So this 1500 we allocate here. This 1500 I am allocating here. So it will become 0. Here 3000 minus 1500 remains 1500. That's all. Now only one unoccupied cell is left. This is the unoccupied cell. Now what is the row total here? 1500. What is the column total here? 1500. So we allocate 1500 in this cell. This will become 0 and this also becomes 0. Our allocations are completed. All the cells are either allocated or blocked. No cell is left. Now you can see all the supply has become 0, 0, 0, 0 and the requirement is 0, 0, 0, 0, 0. That means we have correctly allocated all the units. We have completed. Now number of allocations. How many allocations we got? 1, 2, 3, 4, 5, 6, 7. 7 allocations we got. Now m plus n minus 1. M stands for number of rows. So how many rows we have? 3 rows. Plus number of columns. 1, 2, 3, 4, 5 columns. Minus 1. 3 plus 5, 8. 8 minus 1, 7. That means since the number of allocations are equal to m plus n minus 1, so the solution is feasible or non-degenerate. See here. One of the conditions after completing IBFS, we have to see whether it is non-degenerate or degenerate. If it is degenerate, then we have to overcome the degeneracy and then we apply the optimality test. But if both are equal, the problem is non-degenerate. We can proceed to find out the optimality test. The optimality test will be found by using UI and VJ method. Same table, the same table I am copying here with one extra column and row. The extra column is UI, U1, U2, U3 and row is VJ, V1, V2, V3, V4, V5. 5 columns are there, so 5 V's. 3 rows are there, 3 U's, right? This is the table we'll make to find the optimality test. Now take the allocations. The first allocation is 3500. So I am writing here 3500. I have already allocated here. Then 1500. This is 1500. Right? Next 1000, here 1000, then here is 3000, right? Next 3000, here in this cell 3000, then 2500, 2500, right? Last one 1500. Now we check the totals of availability and requirement, both are same or not. Here column wise 3000, this is 2500, 3500, then 1 2 3 4000, then 3000. Columns are equal. 3500 plus 1500, 5000, 4000, 3 4 5 6 7000. Everything is correct. Now ui and vj method. Take any one of the u value as 0. So in the first row we have only 2 allocations. Second row we have 3 allocations or 2 allocations. Third row we have 3 allocations. So arbitrarily I will take u3 is equal to 0. Remember previous problem I have taken u1 is equal to 0. Now also I can take u1 is equal to 0, right? But the advantage is if we take this 3 as u3 is equal to 0, automatically we will get v1 value as 12. Then v2 value as 12 and this v4 value as 13. Easily, without any effort, I got the value of v1, v2 and v4. How? See here, let us arbitrarily take u3 is equal to 0. The other values of ui and vj can be ascertained by using the following equation. Cij is equal to ui plus vj for occupied cells. Cij stands for the cost of ith row and jth column. So C31, this is the location, third row, first column. So C31 is equal to U3 plus V1. How much is C31 here? 12. So 12 is equal to U3 0 plus V1. So V1 is equal to 12. Whether you calculate like this or directly you can take this 12, easily get. So 3 values already we got it. Similarly this occupied cell, 3, 2. C32 is equal to U3 plus V2. How much is C32 here? 12 is equal to 0 plus V2. So V2 is equal to 12. Come on, 2 values we got. Now we'll use this cell. By using this cell, we can be able to get V4 value. What is the location? Third row, fourth column. C34. So C34 is equal to U3 plus V4. How much is C34 here? 13 is equal to U3. U3 is 0 plus V4. So V4 is equal to 13. So automatically we got 3 values. Now by going up, if we make use this cell, we can be able to get U2 value. What is the location of this cell? 2, 4. C24. C24 is equal to U2 plus V4. How much is C24? 16. So 16 is equal to U2 plus V4 is how much? 13. So bring this 13 to left hand side. So 16 minus 13 is equal to U2. U2 is equal to 16 minus 13 is 3. So we got U2 value 3. Now we can make use this cell. What is the location of this cell? 2, 5. So C25 is equal to U2 plus V5. How much is C25 here? 0. 0 is equal to U2. How much U2 we got? 3 plus V5. So 0 is equal to 3 plus V5. Bring the 3 to left hand side. So 0 minus 3 is equal to V5. So V5 is equal to 3. V5 is equal to minus 3. So we got V5 is equal to minus 3. Again I repeat. I am making use this cell. So second row, fifth column, C25. So C25 is equal to U2 plus V5. C25 is 0. Right? 0 is equal to U2. U2 already we got 3. Plus V5. Bring the 3 to left hand side. 0 minus 3 is equal to V5. V5 is equal to minus 3. Now I am going up this cell. By using this cell, I can be able to find out U1. What is the location of this cell? It is 1, 4. So C14 is equal to U1 plus V4. So 1, 4 it is 12. So 12 is equal to U1 plus V4 is how much? V4 is 13. So I can take 12 minus 13 is equal to U1. So 12 minus 13 is minus 1. So U1 is equal to minus 1. Lastly, if I make use this cell, I can be able to get V3. What is the location of this cell? First row, third column, 1, 3. C13 is equal to U1 plus V3. How much is C13? 11. So 11 is equal to U1 how much? Minus 1 plus V3. Right? Now bring the minus 1 to LHS. So 11 plus 1 is equal to V3. So V3 is equal to 12. 11 plus 1 is equal to V3. V3 is equal to 12. That's all. We got all the values of Ui and Vj. Now we proceed to find out the opportunity cost of unoccupied cells. These are all the unoccupied cells. We have to find out the opportunity cost. If all the opportunity costs are positive, we reach the optimum solution. If any of the opportunity cost is not positive, if any opportunity cost was negative, then we have to change the allocations, right? Now, here, the opportunity cost of unoccupied cells can be ascertained by using the following equation, right? Delta ij is equal to Cij minus Ui. Simply we can say 1, 1. First row, first column. Delta 1, 1 is equal to C11. How much is C11 here? 15. 15 minus U1 minus 1 plus V1. V1 is 12. So 12 minus 1 is 11. So 15 minus 11 is equal to 4. So we got 4 value opportunity cost. Second cell, 1, 2. Delta 1, 2 is equal to C12. C12 is 24 minus U1 is minus 1 plus V2. V2 is 12. So 12 minus 1, 11. So 24 minus 11. So 24 minus 11 will get 13. So this is also one of the opportunity cost, 13. Now this 1, 5. Delta 1, 5 is equal to C15. C15 is 0 minus U1 minus 1 plus V5. V5 is minus 3. So minus into plus minus 3 is equal to. So minus that is equal to 0 minus 4. So minus into minus will become plus, that is equal to 4. So we got here value 4, right? Now C2 delta 21. Delta 21 is equal to C21 25 minus U2. U2 is 3 plus V1. V1 is 12. So 12 plus 3, 15. 25 minus 15 is equal to 10. We got positive value 10. Now 2, 2. Delta 2, 2 is equal to C22 20 minus U2 is 3 plus V2 is 12. So 20 minus 15 is 5. We got the opportunity cost 5. Next is 2, 3. Delta 2, 3 is equal to C23 14 minus U2 is 3 plus V3. V3 is 12. So 14 minus 3 plus 12 is 15. 14 minus 15 is minus 1. First time we are getting opportunity cost minus 1. Next, 3, 3. Delta 3, 3 is equal to C33 22 minus U3 is 0 plus V3. V3 is 12. So 22 minus 12 is 10. 22 minus 12, 10. So we got the opportunity cost 10. Last one, C3, delta 35 is equal to C350 minus U3 is 0 plus V5. V5 is minus 3. That is equal to 0 minus minus 3 is equal to plus 3. Minus into minus will become plus 3. That's all. We have calculated all opportunity costs. And all the opportunity cost, one opportunity cost is negative. This is not the optimum allocation. We have to change the allocation because there is a possibility of reducing the transportation cost. Whatever transportation cost now we get, that is not optimum. We have to change the allocations. How to change the allocations here? There is one negative opportunity cost -1 in the cell delta 23. This is the delta 23. P2 W3. P2 W3. Then, so we make a loop. The minimum quantity in the loop is 1000 units. Hence, 1000 units are deducted from the cell minus sign, and 1000 units will be added at the plus sign cell. We change the allocation as follows. So I will explain you how to change the allocations by making a loop, and then again we have to find out the opportunity costs. So we have seen that one opportunity cost is negative. So this solution is not an optimum solution. How to find out the optimum solution? Now we have to make a loop. Loop is like this: a rectangle or a square where every turning must have 90 degrees angle. So here, from here, because negative opportunity cost is in this cell, so from here I am going to make a loop. How the loop is going to be like this: here I am starting and going upward, then right turn, then I am coming down, then I am coming back home. This is a loop. That means wherever I am taking the turn, that turn should be an occupied cell, right? So here, from whichever cell I am starting the loop, there you should write on positive. This is plus, this is minus, this is plus, and this is minus. So here I have written, this is the plus sign because I am starting the loop from here. Then you can go either clockwise or anti-clockwise. Any way you can go, right? So I am going like this. Clockwise I am going. Even if you go for anti-clockwise, you will get the same solution. Doesn't matter. No change. So from here, the alternative positive, negative sign you have to write. So plus, minus, plus, minus. So here I am starting plus, minus, plus, minus. Now select the minimum quantity with minus figure. Here minus sign, we have two quantities. One quantity is 3500, another quantity is 1000. So whichever is the lower quantity, the lower quantity is 1000. Now we have to make a shifting of 1000 units in this loop. In this loop, we have to make the shifting of 1000. The other allocations will remain same. No change in the other allocations. 3000, 2500, 1500 and this 3000. This will remain same. 3000, 2500, 1500, 3000. Only the allocations in the loop will get changed. So how to change? Wherever there is a positive sign, add 1000. Here minus 3500, here minus 1000. So less minimum allocations with minus sign is 1000. So I am changing 1000. Plus positive sign 1000. Again you have to make a table. The same table you have to make, but the allocations will change. Allocations of the loop will change. The positive sign is in this 14. Right? Earlier this 14 was blank. Now 14, in the 14 cell, I am taking 1000 units, positive. This 3000 minus 1000 will become 2500. So here I am taking 2500. Here 1500 plus sign is there. So 1500 plus 1000, 2500. So there I am taking 2500. Right? And here 1000 was there and minus. So 1000 minus 1000, 0. So no allocations here. Right? Now after changing the allocations, check whether the totals are same or not. If we make wrong, allocations in this cell, in this loop, then our condition will not satisfy. 2500, 2500, 5000. Earlier it was 3500, 1500. Now it has become 2500, 2500, 5000. 1000 plus 3000, 4000. Earlier it was 1000 plus 3000, 4000. But here 3000, 2500, 1500, same 7000. Column wise 3000, 2500, 3500, then 4000, then 3000. That means all the values are correct. Now arbitrarily we'll take U3 is equal to 0. Anything you can take, u1 is equal to 0, u2 or u3, anything. But I'm taking u3 is equal to 0 because directly I can get these three values. This v1 value is 12, then v2 value is 12, then v4 value is 13. Directly. Even if you substitute in this equation, you will get the same values, right? For other values, from here I am going upward, this cell. If I make use this cell, I will get u1 value. What is the location of this cell? 1, 4. So C14 is equal to u1 plus v4. How much is C14? 12. Is equal to u1 we don't have plus v4. v4 is 13. That is equal to 12 minus 13 is equal to u1. So u1 is equal to minus 1. So here u1 is minus 1. By using this cell, I can be able to calculate v3. What is the location of this cell? 1, 3. So C13 is equal to u1 plus v3. So C13, how much is C13 here? 11. So 11 is equal to u1. u1 is minus 1 plus v3. 11 is equal to P31. That is C13. C13 is equal to u1 plus v. So 11 is equal to minus 1 plus v3. So this minus 1, if I take it to the left hand side, it will become plus 1 is equal to v3. So v3 is equal to 11 plus 1, 12. We got here 12, right? Now we can make use this cell to find out the value of u2. 2, 3. So C23 is equal to u2 plus v3. So C23 how much here? 14. 14 is equal to u2 plus v3 how much? 12. That is equal to 14 minus 12 is equal to u2. So u2 is equal to 2. Got the value of u2, right? If I make use this cell, I can be able to get v5 value. What is the location of this cell? 2, 5. So C25 is equal to u2 plus v5. So C25 how much? 0. So 0 is equal to u2. u2 is 2 plus v5. v5 we have to find out. Then 0 minus 2 is equal to this plus 2. If I take it to the left hand side, it will become minus 2. So v5. So we can say v5 is equal to minus 2. v5 is equal to minus 2. That's all. We got all the values of u, I and vj. Now we have to find out the opportunity cost of unoccupied cells again. The formula to calculate opportunity cost of unoccupied cells, delta ij is equal to Cij minus ui plus vj. Same formula, right? What is the location? 1, 1. So delta 1, 1 is equal to C11 minus u1 plus v1. That is equal to C11 is 15. So orally also, without writing this, we can directly calculate. C11 is 15 minus u1 plus v1. So how much is u1 here? Minus 1 plus v1. v1 is 12. So 12 minus 1. 12 minus 1 is 11. So 15 minus 11 is equal to 4. We got opportunity cost 4. Here also 24 is the Cij value. So 12 minus 1 is 11. So 24 minus 11 is 13. So we got 13 value opportunity cost, right? Here the value is Cij 0. So minus 2 and minus 3. So minus 2 minus 3 will become minus 2 and minus 1 will become minus 3. So 0 minus minus 3 will become plus 3. So positive opportunity cost. Here 25. 12 plus 2 is 14. 25 minus 14 is 11. Here 12 plus 2, 14. 20 minus 14 is 6. Here 16. So 13 plus 2 is 15. 16 minus 15 is plus 1. Here 22. So 12 plus 0 is 12. 22 minus 12 is 10. Here 0 minus 2 is minus 2. So here 0 minus minus 2 will become plus 2. right? So we can see here all opportunity costs are positive. 4, 13, 3, 11, 1, then here 10, 2. All the opportunity costs are positive. So now we can proceed to calculate the minimum total cost. What is the minimum total transportation cost? Now we can easily find out. Since all the opportunity costs are positive, since all the opportunity costs are positive, so we reach the optimum solution. The optimum cost is allocations. Then second we'll take units. Then we'll take cost per unit. And lastly we will take total cost. As usual, every problem we are doing, the first P1 to W3. P1 W3. How much? 2500 units, 11 rupees. Then P1 W4. P1 W4. 2500, 12 rupees. And P2 W3. P2 W3. P2 W3. 1014. Then P2 dummy. P2 dummy. How much? 3000. And next one is P3W1. P3W1 how much? 3012. 3000 units, 12 rupees. Then P3W2. P3W2. 2500 and 12 rupees. Lastly, P3W4. P3W4. 1500 units, 13 rupees. That's all. Now we have to find out the total transportation cost. Multiply the units with per unit. We'll get 2500 into 11. That comes to 27,500. Next one is 2500 into 12. It comes to 30,000. Next come 1000 into 14. 14,000. 3000 into 0. 0. 3000 into 12, 36,000. Then 2500 into 12, it comes to 30,000. Then 1500 into 13, it comes to 19,500. Now we have to add up. So 27,500 plus 30,000 plus 14,000 plus 36,000 plus 30,000 plus 19,500. It comes to 1,57,000. That's all. This is the end of the problem. See here, this problem is very, very important from examination point of view. First instance itself, you may not be able to understand. Watch the video twice, thrice. Because two new points I have covered up in this video. The first new point is regarding the unbalanced problem. So we have made it balanced. Secondly, all the opportunity costs are not positive. One opportunity cost is negative. So whenever there is a negative, make a loop and change the allocations. The loop will be started from the point where we have negative opportunity cost. Here negative opportunity cost here. So I'm starting the loop from here, either clockwise or anti-clockwise. Any way you can go. So from here to up, then take the right, then down, then back home. This is called the loop. Then write the alternative sign, plus, minus, plus, minus. Two minus signs are there, two plus signs are there. In the minus signs, what is the minimum quantity? 1000. So change the allocation 1000 in this loop. Wherever there is positive, add 1000. Wherever there is negative, deduct 1000. Like this we have changed and make these allocations. Finally, we got all opportunity costs are positive, so we reached the optimum solution. So this is the end of the problem. Inshallah, we'll continue the next problem in the next video.